Ever wonder how we managed to fit like massive mountains and these huge sprawling forests, onto a single map?
Hmm.
Well, get ready to find out
Yeah.
because today's deep dive takes us into the world of topography.
Oh,
We're going to be guided by topocores.pdf,
right.
which is, I gotta say, a pretty fascinating document.
I know.
It basically outlines all these techniques and applications of this, honestly, essential field.
Yeah, it's
And
tough.
and get this,
Yeah,
it's all through the lens of a forest engineer,
that's right.
which is a profession that
Yeah,
you might not realize, like, how much they rely on understanding the Earth's surface.
it's true. Yeah. I mean, we take maps for granted,
Yeah.
but they're really the result of, centuries of like innovation and just countless hours of like really meticulous work.
So, okay, I think we need to back up just a little bit.
Sure.
For those of us who, maybe skipped that topography class,
Yeah,
what exactly is topography?
sure.
I mean, it sounds kind of technical when you just say the word, so.
At its core, topography is basically the science of accurately, like depicting both natural and human-made features on the Earth's surface.
Okay.
So think mountains, valleys, rivers,
Right.
but also, roads, buildings, and even those property lines
Oh, okay.
that determine where your backyard ends and your neighbor's begins.
I see, I see.
Yeah,
So it's more than just like pretty pictures of landscapes. It
Mm.
sounds like precision is like key here.
absolutely.
Yeah.
Yeah, topography is all about like accurate measurements and calculations. It's about really understanding the shape and the elevation of the land, and then, representing those spatial relationships in a way that's useful for everything.
Yeah.
I mean, from navigation to construction to, yes, even managing a forest effectively.
This document mentions something called scale,
Right.
which I'm guessing is a pretty big deal when you're trying to shrink, say, a whole forest
Yeah.
onto a piece of paper.
Scale it's fundamental to topography.
Yeah.
It's essentially the ratio between a distance on a map and the corresponding distance on the actual ground.
Okay.
So think about it. A map of your city might have a scale of like 1 to 10,000,
Okay.
meaning 1 centimeter on the map represents 10,000 centimeters or 100 meters in real life.
That makes sense, yeah. But things, I think, get even more impressive when you start thinking about all the variety of the tasks that a forest engineer, actually has to tackle.
Yeah,
Like, it's a lot.
precisely. And our document highlights how they use topography for everything.
Right.
I mean, for establishing forest boundaries and planning the layout of, new plantations to overseeing construction projects, within those forests.
Wow.
They're essentially like spatial problem solvers,
Wow.
ensuring that human activities within a forest are both, efficient, but also sustainable.
It's amazing to think how this, like, seemingly specialized field
Right.
is actually connected to so many aspects of our lives,
Yeah.
especially, in our world that's increasingly digital.
Right.
And that makes me wonder, like, have you ever stopped to think about how topographic data underpins so much of the technology that we use every single day?
Sure.
Take GPS navigation, for example.
Oh, absolutely.
Yeah.
From the apps that we use to find the nearest coffee shop to the sophisticated systems that guide, self-driving cars, our ability to pinpoint locations and navigate our world really relies heavily on the principles of topography.
It's like this hidden language that shapes our modern lives.
It is, yeah.
But before we get too far ahead of ourselves,
Yeah.
I am curious to explore, like, the tools and techniques that make this spatial understanding possible.
Okay.
How do we go from those real-world measurements to those incredibly detailed maps and models that we see everywhere?
Yeah, that's a fantastic question.
Hmm.
And it takes us into, this fascinating realm of geomatics, which is a field that kind of encompasses a whole suite of spatial sciences.
Geomatics.
Yeah.
Geomatics. Okay, I'll
Yeah.
admit that one sounds like a little intimidating when you say it out loud. It's
Wow.
like the VIP section of spatial sciences.
It kind of is. It might sound like a mouthful, but,
Right.
think of it this way. If topography is about, like, accurately depicting the Earth's surface,
Yeah.
geomatics is, like, the toolbox that makes it all possible.
Okay, I like that, yeah.
Yeah.
So what kind of tools are we talking here? Like, are we breaking out the laser levels?
We're talking everything from the traditional surveying techniques that you might, picture in your mind, think like compasses, measuring tapes,
Yeah.
to like cutting edge technologies, like satellite imagery and laser scanning. And our document specifically mentions a few like key branches of geomatics.
Okay.
And those are geodesy, photogrammetry, cartography,
Okay.
remote sensing, and geographic information
Yeah.
systems,
Okay.
or GIS for short.
GIS. Got it.
Yeah.
Whoa. Okay. That's a lot to unpack.
Yeah.
Let's start with geodesy since you mentioned it deals with like the Earth's shape and size.
Right.
I'm guessing that's important for making maps accurate.
It's crucial.
Yeah.
Imagine, like, trying to flatten the peel of an orange.
Oh, okay.
It's just not going to lay flat without some distortion, right?
Right.
Geodesy helps us tackle that challenge, but on like a global scale.
Okay.
So it provides the framework for understanding, the Earth's curvature and how to accurately represent that on these, flat maps that we rely on.
Every day. Yeah.
Every single day, exactly.
That makes sense.
Yeah.
So once we have that framework, is that where photogrammetry comes in?
Yeah.
Because I remember you mentioned that it involves using photographs to
Right.
create these maps and models.
Exactly, yeah. Think about, like, those incredible aerial photos you see, the ones that look like you could just reach out and, like, touch the rooftops.
Yeah.
Photogrammetry takes those images, often, captured from airplanes or drones,
Right.
and uses them to create these detailed 3D models of the Earth's surface.
It's like piecing together this giant puzzle.
It is.
But instead of cardboard, we're talking about like precise measurements and digital terrain models.
Yeah,
That's got to be incredibly useful for all sorts of things.
Oh, absolutely.
Yeah.
Photogrammetry has, revolutionized fields like urban planning,
Wow.
archaeology, even disaster response, right?
Oh.
Allowing us to really visualize and analyze landscapes with incredible detail.
And once you have those accurate representations, you
Yeah.
need a way to turn them into something that's like visually clear and
Yeah.
informative, right?
Right, and that's where cartography comes in,
Okay.
which is, it's the art and science of map making.
Okay, so cartographers are the ones who take all that raw data
Exactly.
and turn it into those beautiful maps that
Yeah.
we see, like hanging in classrooms or
Yes.
national parks or,
wherever.
Yeah.
Precisely. But here's where things get really, really interesting, right?
Okay.
Remember those layers we talked about in GIS?
I mean, how we can have like a base map with like streets and buildings and then add like layers on top of it for things like population density.
Yeah.
Or maybe even the locations of like all the best hiking trails.
Exactly. Yeah, GIS is like the ultimate mashup of spatial data.
Okay.
It takes all that information we've been talking about, topographic maps,
Oh.
aerial photographs, even data from satellites,
Okay.
and like integrates it into this powerful system for analysis and visualization.
It's like having a virtual model of the world, like right at your fingertips.
It is.
Where you can like zoom in to see the smallest details or zoom out to understand like the larger patterns and relationships.
And it's not just about like looking at data, right?
Yeah.
It's about actually using it to answer these like complex questions and to make like informed decisions. So like say you want to know how traffic patterns are affected by, new construction.
Yeah.
GIS can help you with that.
Wow.
Or you need to like predict the spread of a wildfire based on wind patterns and vegetation.